Good morning. I'm going to go through worksheet 10.3 again. Hang on. Yep, it's 10.3. Okay, that was with arcs and chords. Okay. The first one, almost everyone did very well. You don't even have to break down the circle like I had in the first video. Actually, all you have to do is remember that when you know two segments, if two segments are congruent, their arcs are congruent. If two angles are congruent, the arcs are congruent, which means your segments are congruent. So what they gave you is they gave you that two of your segments are equal, which means that the segments are congruent and the corresponding arcs will be congruent and the angles. So if we look at BC and FE, did I write it right? FE, yep. We're a little off, but all right, so not to scale, guys. So BC and FE are congruent. Let me redo that. All right, move that over here. All right, so they're congruent. Right. So congruent segments give me congruent arcs, which means my angles are going to be congruent. So these two angles in here are congruent. And so we know EAF and BAC are congruent angles because the arcs are congruent, and then we can say those chords or the segments are congruent. Okay, and the next thing they gave us is they gave us that angle BAD is equal to the measure of arc EG, which is 90 degrees. So if E to G is 90, that means likewise BD is 90. So this is 90, this is 90, and all because BAD is 90 degrees. So if BAD is 90, okay, that means that its vertical angle is also 90 because these are two intersecting lines. Yeah, vertical angles. So this is 90. This is 90 because of the fact that EG is 90. Its corresponding angle is, its central angle is 90. BAD, its the central angle, but then the arc intersect is also going to be 90. So that's how that's using that theorem. And let's see, so we've got EAG, so angle EAG we have as 90. Arc BD is 90. Okay, when they ask about angle BAC, we just did that using this. Angle EAF is well, BC and EF. EAF, how did I get the wrong letter there? Well, we just did. All right, you see? And then arc BD is going to be congruent to arc EG. And you're done. Okay, and if it's a line, BD is congruent to EG because I wrote it wrong. All right, that's that one. For 5, 6, 7, and 8, the formula is the Pythagorean formula. We use Pythagorean theorem. So you're going to identify your X, your Y, and your R. Okay, so when we're with circles, we're going to talk about X, Y, and R for pre-calc. That's what we do. We learn a shorter formula next year using X, Y, and R, but in this case, it's a bit longer. So we're given that the distance from the center to a line segment, that's our Y. We're going to call that our vertical. They give it to us as 8, so our distance is 8. The x squared is going to be the center, half the chord length. So that's going horizontally. And then r is always going to be a radius. So in 5 and 6, we're not given the radius. We're given the distance from the center, which is 8. And we're given the chord length, or half of it, which is 15. So I have 15 plus 8 squared. So I get 225 plus 64. That's my radius squared. So this is going to be 289 is my radius squared. Then I take my square root. Okay, square root of 289 is going to be 17. And you're done. All right, so we know that the radius is 9. Okay, so distance from J to M, if half the radius is, if half the chord is 15, then the whole chord is 30. So if two chords are the same distance or equidistant from the center, the perpendicular line, so line perpendicular to the center to that chord bisects it. So they give us 15, which means the total length is 30. And then the distance from N to M is going to be 17. N to M is a radius. So chords get bisected, so we double them. And then radius we find by doing the distance from the center squared, okay, plus half the chord squared. So for 7 and 8, what we're going to do is we're going to take, we know we know the distance is 7. Okay, so we're going to have 7 squared. I know that half the chord is 24. And then I'm going to get a radius. So distance from P to R though, PR is the entire chord length. Okay, it's going to be congruent to PQ. PQ, if we double 24, we get 48. So they're congruent. So we're going to go PR is 48. And then SQ is going to be your radius, because that's from the center to a point on the circle. That's our radius. So so you plug everything in here, 7 squared plus 24 squared, is your radius squared, so 49 plus 24 squared. It's nearly 576, almost said 96. Don't ask why. All right, that gives me 625. And now you just take the square root of 625. All right, which is 25. And you're all done. Thank you guys. Hope this is helpful. So if you want, look it over. And if you look at numbers 9, 10, and 11, you're going to be doing something very similar to this. If they give you the radius, then you're doing subtraction. So you would have your radius squared, whatever it is, minus whatever the other one is squared, and that gives you your missing leg squared. But we don't really work with these in the pre-calc. We do some of it. If you go on calculus, they come back to it a little bit, but only once in a while with some applications. All right. Hope this is helpful. Thanks. Bye.